When we first looked at carbon nanotubes, there were numerous challenges. So first, from a technical standpoint, they're not easy to handle and work with and manipulate and disperse into liquid coatings and resin systems. And of course, cost was an issue. We were able to work at the outset with carbon nanotubes, create scale and efficiencies that now allow us to provide economical products. Carbon nanotubes are nanoscale, but they are the stiffest, strongest material known. Much stronger than steel, more electrically conductive than copper, and they provide some very unique benefits to our coatings. We've really identified the form factors and the structure of carbon nanotubes that not only work best in our coatings, but also are economical, so we can provide economical solutions to our customers. Carbon nanotubes were discovered in 1985 by researchers at Rice University. Prior to that discovery, there were only two forms of carbon, diamond and graphite. Based on our knowledge, TESLAN NanoCoatings is the first one to utilize commercial scale quantities of carbon nanotubes. The ideas for utilizing these carbon nanotubes came from my work in the aerospace industry. I was working at Lockheed Martin, and I had severe problems as an engineer dealing with cadmium plating on parts. Tremendous amount of environmental concerns, tremendous amount of rework. We figured there had to be a better way to do the same thing. The better way to protect steel is to provide the toughest, most resilient barrier coating. We utilize carbon nanotubes to provide a high level of electrical conductivity and sacrificial metals such as zinc to provide the cathodic protection necessary. Historically, one of the biggest problems with protective coatings, in particular organic or paint-type coatings, are they're insulative. They cannot conduct electrons in a galvanic cell. So taking a traditional resin system and making it conductive, electrically conductive with carbon nanotubes solves much of those issues.